All right, so our goals for the next hour and a half is you've been called to go ahead and solve some customer's mystery. Okay, some customer's got an issue. You're trying to go in there and solve it. And what is the process? What are the steps that you need to take? What are some of the questions you need to ask in order to help them out? Now, this may be an internal customer in your company. This may be someone like for myself. I go out and I do this for, fun and profit, and actually be a real customer on the outside world. Okay, and some of the issues with dealing with an outside customer is some of the questions that I have to ask. They may or may not have the answers to, and the great thing about the fact that they're calling me in is because probably by then they've suffered enough that they'll at least try to get the answers. Whereas if you're working with an internal customer, you're at the same company, you both work together, then sometimes it's a little hard to get your answers. Okay? Because it's so easy to ignore. I know, what did I just step on? I don't know about it. It's so easy to ignore somebody from your own company, whereas oftentimes it's hard if they've paid somebody to come in from the outside, especially the higher up the person is who paid you to come in, the more likely you are to get answers. Okay, so that makes it nice. So I'm kind of spoiled, all right, because when I come in, they've already suffered enough that they'll pretty much, give me whatever I want. So that kind of makes it nice. So I bear that in mind, that I'm kind of coming from that scenario. So a lot of the things that I'll ask for or I'll need, maybe from y'all if you're working with an internal customer or somebody else in another business unit or somebody in your own business unit, you might not approach it the same way. Okay, I'm approaching it as an outsider. So we'll look at what questions to ask. We'll look at what tools you need or what tools you would like to have. And once you have the traces, now what do? Because it's so easy to go ahead and capture lots and lots and lots and lots of data and then spend hours and hours and hours and hours looking at it. Okay? And it's too easy to get caught in a vortex. All right? So the goal is to look at the packets for the shortest amount of time possible. That's the goal. Right? Now, not to be really personal with y'all or anything, but I charge by the day. I don't charge by the hour. I charge by the day. So if I can come in, if I've done enough prep work, walking in the door, and if I can get into the right place at the right time, then I get to leave by 9:30. You got to pay me the whole day. So I am very focused on being as efficient as possible. Okay. So that's what we're going to look at. Now, so the client interview. Now, so a client calls you up, they're like, oh my gosh, our network's so slow, or oh my gosh, our application's so slow, or oh my gosh, users are complaining, can you help us? Could you just look at this trace file? I get that a lot. Could you just look at this trace file? No, I can't just look at that trace file. You've got to answer a couple questions first. Otherwise, I'm going to spend hours looking at it. And because it's going to be interesting, there's going to be stuff in there, there's going to be good stuff. But I won't solve the problem. And the goal is to solve the problem. Okay? So, some of the things that you should ask in the beginning. The more data, the better. Now, I'll be honest with y'all. I've been doing this since '96. Started off with Network General. And my client interview skills have improved over the years. Okay? And it is really a mixture of the social engineering and then the technical. Right? So when I started, I just went ahead and stuck a tap on there, stuck my little distributed sniffer on there, started capturing away and looked at the expert and then just ran with it. 12 days later I had an answer. Now I'm a little older and a little wiser, and I ask a lot more questions in the beginning, save a lot more time. So the more questions you ask, the more information you get, the easier your life is. And the more people you ask. Because, like, let's say I go ahead and I ask, Greg a couple questions about the environment, and then I turn around and I ask Roger a couple questions, and then I ask Fred a couple questions. I'm going to get 3 different viewpoints, which, maybe you didn't bring up, blah, blah, blah about that load balancer, and you didn't bring up blah, blah, blah that we just implemented this new routing protocol, and you forgot to mention about that, the fact that this goes to the back-end database server for that web server, and that's really what's going on. But between the 3 of you, I'll get a lot better picture. So the more people you ask, the more info you get. So let's think about what we should ask. Okay? You want to think like a reporter. All right? Ask the 5 W's. So number 1, who is complaining? Your goal is to look for patterns. So if I'm asking, who's complaining, I want to know, is there any pattern towards any of those people? Are they all in the same physical location? Is it a particular office? The people in Boston are having a hissy fit, whereas the people in Birmingham seem to be just fine and dandy. Okay. Or is it a case of people in a specific work group or business unit? Accounting people seem to be happy, but marketing people are, because they've got those much bigger files, and they seem to be having a conniption. Is there any pattern to the people who are complaining? Okay. Then we want to look at, if they're in the same location, are they in subnets? Some people, when they do their network design, go ahead and subnet based on physical location, like every floor is a subnet. Some people, when they do their design, they put people in certain subnets based on their work group. It depends. I have to ask. I need to know that. So just because I have an opinion on how certain things should be done, that doesn't mean that that's how they're done there. Or based on their environment or what they need, could be, the best answer for that situation, but, it's not what I've done. Okay? So I've got to ask that. All right? Are they all in the same subnet? What are they complaining about? What specifically? If they call and they say the network's slow, I need more information than that, okay? I have got to have some specifics. Is it slow during certain times? Is it slow for certain applications? If it's slow for certain applications, which applications? What are the IP addresses of the servers involved? Do you have that documented anywhere? What has changed in the last little bit? All right. So who's involved and specifics on that? Then, if they have any applications that they rely on. Those are my, what's the word I'm looking for? Not suspects, but accomplices, okay? So if I have someone, like yesterday we looked at an issue that involved HTTP. So who is the accomplice protocol for HTTP? Yeah, DNS, okay? Because you've got to do DNS before you can do HTTP. Okay, you've got to pretty much do DNS before you do anything, okay? So those 2 protocols have to work together. If we're doing Active Directory, I need to know if we're doing dynamic DNS. So if we're doing Active Directory and we're doing dynamic DNS, what other protocol is going to be an accomplice? Okay, could be LDAP. All right. Okay, and I missed you, sorry. Go ahead. Could be LDAP. Right? What other protocol would be involved if we're doing dynamic DNS and Active Directory?
DHCP?
That's what I'm looking for. Who did it come from? Here we go. Help me out. Okay? So it would be DHCP. All right? let me try that again. DHCP server goes ahead and gives out an address. He's got to update the DNS server that says now, host so-and-so with IP address such and such. I want you to update your DNS database with that, please. Thank you. All right. That's dynamic DNS. Okay. So I have to know in this environment if they even do that. All right. And I'd have to be able to capture that protocol as well. Okay. So you have to think about what kind of protocols are in play, because that's going to help you think about where should you be when you're capturing. Now, so what are they complaining about and who's involved? Then, where is everybody physically? Now, in the perfect world, right, so in Bettyland, where everything is perfect and I get whatever I want, right, I like to be capturing at the client and capturing at the server at the same time. Okay? I like to go ahead and put a nice, great big giant capture device at the server and capture everything, and then go ahead and capture with, a laptop or whatever at the client and watch what they do and feel their pain, right? Because you can tell from people's faces at what point is this not meeting expectations. So sometimes when you look at something, you're like, oh my God, that is so slow. What is up with that, right? And yet they're like, that's perfectly normal and cool. But you're like, I would shoot myself in the head if I had to deal with this every day. Okay, and then they'll get to a point where they're trying to load something up and you're like, oh, that's why you called. Okay, but until you physically see that, it's really hard to get that impression just from the trace file itself. All right, because in my world, I start to get excited when stuff takes longer than 30, 50 milliseconds, because I have the attention span of a 4-year-old. But in some environments, if we're doing like long distance, let's say that I'm, pulling data from, stuff in like New Zealand. All right, well then my expectations are a little bit lower, okay, because I live in Georgia, if you haven't picked up on that yet. And I finally got a Diet Coke today, I'm so excited.
You're loyal.
I am, because every day I look, and by the time I go to look, they're all gone, and I can't drink a Pepsi product. I live in Atlanta, okay? We shop at Home Depot, we ship UPS, we fly Delta, and we drink Coke. Okay? So, anyway, sorry. So I want to feel that client's pain, and I want to understand where, their face changes. I watch their face, and I get their impression. All right. Another thing that I do is when I'm capturing their client, I go ahead and give them a little tiny batch file, because bear in mind, I'm capturing the client and everything they're doing. Now, they're doing like 27 things all the time, right? And then at the server, I'm capturing, or maybe I'm capturing in front of many servers at some interconnecting device, and I'm capturing, 30, 50, 100 servers. Trying to match those two is going to be a thrill. All right, and trying to correlate where all that is together is going to be a challenge. All right, so what I like to do is go ahead and we're capturing everything over here, okay, and then I come on back to the client, okay, and I put a little batch file on their desktop. All right, and I have it, I don't know, ping the default gateway or ping something that I know what it's going to do. And then every time the client opens the application and tries to do whatever they're throwing the hissy fit about, I have them go ahead at each step, open the application. Now stop, run that little batch file, double click on that for me on the desktop, thank you. And then we go ahead and we log in. I'm like, now wait, don't do anything else, don't click, don't you click. And go ahead and double click on that little batch file for me now. All right, and then we log in, and now we're going to pull up some kind of user data. All right, you fill that out, and you go ahead and hit submit. Don't click on the records yet. Wait. Go ahead and don't click on that batch file. And then that way I've got a pane separating everything. And it makes it a lot easier to go back in that trace file and go, okay, here's step 1 of that application. Here's step 2. Here's step 3. And I'm taking notes as we're going along. Okay. Now, since I got my handy-dandy, there it is, handy-dandy client application capture device, now sometimes I'll go ahead and I'll actually film their screen as we're going along. And that makes it a lot easier when I go back and I look at the trace file, because I go to like 52 different places and I meet 87 different people, and my buffer's full. And I forget stuff a lot. So I go ahead and I have, I just sit there and film them. Okay? And I film their screen, I don't film them because, it freaks people out. But I just sit there. Like right now, Denny's filming me, he's filming me. It's freaking me out. So forgive me, I get a little nervous when I get filmed. So I go ahead and film the screen, and then it makes it a lot easier for me to go ahead and remember everything that they did and what points am I looking for certain things. Also, it helps me search in the trace file based on words that I see in the screen. So like, let's say we've got an HTTP type of application and it's running in clear text. I can search for the words that I see on their screen to correlate with that process. Or it's a database application, or whatever. It's their terminal serving into something, or whatever. Okay, I can go ahead and look for that. Makes it a lot easier to go through 8 billion cajillion packets. Then I look at when. When did it start? All right. Has it always been this really ridiculous, or did it just start? Has it gotten worse over time? Give me some kind of impression. Then, most importantly, why are you calling me? Because if the answer to this question is simply expertise, we just don't have somebody that does nothing but look at trace files all day. Now, y'all are sick because you got somebody who looks at trace files all day, right? But not everybody in their environment has somebody who looks at trace files all day. So if they're looking for expertise, then that's no problem. That's great. I live for that. But if they're calling me because they don't have time to look at the trace files, they sort of use Wireshark a couple times, but they don't want to go through it all because we don't have time, and we just want to capture some stuff and then send it to you, then I'm going to have to raise my bill rate for that. Okay? Because what's going to happen is if they're that pressed for time, then when I go to ask some of these questions, because you're going to look at the trace files, and then you're going to start to ask questions based on it. And when I start to ask those questions, they're not going to be able to take the time to answer me. So my bill rate's going to need to go up because it's going to take me longer. Okay? So I need to know that ahead of time. I have a varying bill rate. All right. Sorry, Glenn. Sorry. Got caught on the table. Okay, here's my mouse. Okay, tools. Some of the things that I think I need in order to do this. Wireshark, of course, right, because we're going to need to capture all those packets. Okay. And depending on what I've got, how many places I need to go, I'm going to need some taps. Now, when y'all went to the vendor's cocktail reception last night, everybody get a chance to look at the tap people? Some? No? Yeah? No? Okay. All right. So y'all should know that a tap is a physical layer 1 device. Who remembers hubs? Yeah, there we go. Let's all show our age, all right? In the beginning, there were hubs that they were good. Okay. But, yeah, really. I remember those. Those were so wild. I remember ARPANET. Okay. I was told about it. I wasn't there, of course. But a tap is a layer 1 device. All right. There's no brains in here. Well, there are some brains, but we're not making any routing decisions, any switching decisions. We're making no decisions here within the tap. So, for example, let's say that I have 2 switches. All right, I've got a core switch, I've got an edge switch, and I want to see all the traffic in between. That's my goal. So I go ahead and I take the cable out of the core switch to the edge switch. Let me say that again. I take the cable out of the core switch to the edge switch. Now, what are my concerns? Okay, yes, that would be a change control issue. All right, so I come in at midnight. You'd be amazed how many times I've come in at midnight. And during the change control window, all right, and take that cable out of the core switch, plug it into port A, take the, go ahead and put another cable into port B and plug it into the edge switch, all right. Now in line, it's a splitter. That's all a tap is a splitter. Then, okay, and in fact, actually, once I get it powered up and we're back in line, I can actually unplug it and walk away. So it's just a splitter, all right. Now, of course, I won't be able to capture anything if I don't have power. But the nice thing is, as far as like a single point of failure, I can lose power. Whoop-de-doo, all right? I'm still going to have link. I'm still going to be passing traffic, okay? Then I go ahead and I put my sniffer on port C, all right? Now, this particular tap's from Network Critical, and because you want to think about the fact I've got an edge switch and a core switch, right? What speed do y'all think those are going to go at? Gig. That's what I want to hear. Thank you. Who said gig? Oh, gosh.
Well,
All right.
Problem with some hubs, Betty?
Yes, sir.
Problem with some hubs is it's a high enough speed that they switch back to switch. They may not actually be a hub at a high speed. They may
Yeah.
have to switch.
Yeah, that's one of the reasons I don't use a hub in a bit land. No. No. Number one, you can't even find a hub anymore, hardly, unless you really hunt, right? And then, number two, exactly like Greg just said, if you have bought a hub, a real hub, and on the box it says hub, what it really means is if you were ahead and popped the case off of it, you'd see that it really is a switch. There's no difference in the electronics, all right? And we'll get to the point where it'll start going ahead and either A, it will learn and then start stop flooding bit per bit. Okay, remember back in the real 3-com hub days and it really did flood bit per bit? Remember that? Wasn't that good? It was great to snip that. Made it so easy. Oh my God. So it'll learn and then it'll start, it'll get to a point where it'll start switching into switch mode and then all of a sudden I ain't got no packets no more. Or the other way, it'll get to a point where it's flooding all the time because it is oversubscribed. Okay, so you have to worry about that kind of thing. That's why I never use the hubs, and that's why I'm kind of anti-spam. Sir.
One of the vendors yesterday was pushing a product that was sort of amalgamated everything from all the taps and switches and span ports, mirror ports, and the whole system, so you could go in at any time. Do you like that idea?
Gigamon, right?
Yeah. Do you like that idea?
Sure. Yeah.
But how many people do that? What percentage of companies do that?
There we go. I got one hand up. Okay. Who are you with?
Stanford.
There we go. We saw 45,000 IP addresses yesterday. I think you were in here for that, right? No, it was like the first day. It was the first day, and we saw 45,000 IP addresses. I like that our second diet. Sorry, I'm having drinks in here. Sorry. But yeah. Now, bearing in mind, okay, because I have yet to get an answer from the Gigamon people, so I'm not really sure where the time stamping is happening. That's what I want to know from the Gigamon. Is anybody from Gigamon here? Because I want to know where the time stamping is happening.
Right, that's a good problem. It sounds like only 1% of the companies, based on a small survey, are actually doing it.
It depends. It depends. It depends on the size of the company. The bigger the company, the more likely you are to have that type of tool, because it ain't cheap.
Yeah.
Yeah. Okay.
Have you personally seen it at all?
Me personally, if I ever use Gigamon, no.
Have you ever seen it?
Oh yeah. Oh yeah.
Here.
Yeah. Well, no, other than here. Oh no, yeah. Because I have, because bear in mind, this is like my third Shark Fest. So back in 2008, my first Shark Fest, I met the Gigamon people. And
it was ANUE Systems.
oh, Anui.
Yeah.
Okay. Right. Yeah. Hemi, Sacker. Yeah. Hemi didn't come this year, but yeah. So I have seen both the Anui products and the Gigamon products. I just personally haven't gone to any customer that has them installed and to be able to use them. But I've had them both demoed. I've had a chance to use with the Gigamon to actually have access to their application, so I can see how the filters work, and it's like really cool. I mean, it is literally drag and drop, which is super sweet. I just have not had a chance to use it in real life, which is why, because see, what's on the table is things that I personally have actually used. Yeah. So not that it's not super awesome. I just haven't had a chance yet. And that's something I want to know. Where do we get time stamped? Because if we're funneling all that into one place, where is it getting stamped?
Yeah, that's a very valid question.
Okay, because the taps, they don't stamp. They don't time stamp. All right? Whoever sniffs it stamps it. Okay? So, and time stamps in Bettyland are like the most critical thing on the planet. Because normally what happens, all right, I'll just be honest with you, right? The network guys call me to prove it's not the network, right? So that's just how it really works out. And so my goal is to go ahead and look at the application response time and prove that it's either A, the server, or B, the application, or what, C, D, and S, right? And So I want to go ahead and watch a command fly across the wire, and I want to watch a response fly across the wire, and I want to know how much time it's spent in between. Well, if my timestamps are being done some other place, you know, that makes a big difference where you are physically when you actually do the timestamping. You know, if you're measuring between the command and between the reply, where you are physically when you physically timestamp matters. So that's why I want to know the answer to that question. I don't know yet, so I haven't had a chance to use it yet. Okay. So, all right, okay. Over to Percy, yeah, that's right. I'm like, for what's like, I lost my spot.
So, does that one have interchangeable fiber?
This particular one, no. This particular one's copper only. Okay. Now, did they make them in fiber? Yeah. Okay. But yeah, this particular one's copper only. And this particular one, one of the reasons why I love this one is because this particular one, so remember how I said we've got edge 1 and core 1 connected here, and then I'm capturing off of port C, right? Now, remember how I asked, you know, is this gig? And y'all went, uh-huh, right? So if I'm going gig, I'm going full duplex, right? So my edge switch and my core switch can talk at the same time, right? Okay. So how come I'm only plugging into port C? What's up with that? Right? So this particular tab will go ahead and aggregate those packets together as they're received. So it's merging the two streams together. Well, what's going to happen if my core switch and my edge switch ever, at the same time, between the two of them, both one or the other is over 50%, I have a spike, and I merge them together. 75% plus 75%, it's a little over 100%, isn't it? Yeah, even in my math, I can't do math, and I know that. So, those of you who've seen me present know that I can't do math and I can't spell. Okay. We all have a gift, and those are not mine. So, the reason I love this one is because I can configure it to go ahead and stay split out. So edge 1 sniffer here, core 1 sniffer on the other port, okay, and then I would have to merge the traces together later, or I can go ahead and configure it to merge them, because let's say in my environment those things never go above 10% anyway, so I'm good as gold. Go ahead and merge them, and then it's logistically easier for me to only capture one. Or sometimes I want to go ahead and merge them and then make 2 copies because I got an IDS somewhere else, you know, and the security people want it and I want it. So I love that. All right, and that's a layer 1 device. Now, so that is usually what I put in front of servers. Okay, because the whole beauty of a layer 1 device is there is absolutely no worries about adding, you know, latency that is of any concern. And any concern in Betty land is in nanoseconds. All right, because you know how PCAPs only go to micros anyway. So that's all my granular is going to be anyway. So there's no additional latency because of that tab that is measurable in what I'm capturing anyway. All right.
You can change that. You can do that.
In a PCAP format?
Is it going to be meaningful?
Is it going to be meaningful? Yes. And we'll go to that in just 1 second. Can I change it in a PCAP? Not that I'm aware of. Can you change it in a PCAP? I thought PCAP only went down to milli micros.
Micro is a nano.
No. Milli, micro, nano. You're right. I know what you mean. But in my brain, this is why we love Greg. Greg keeps me technically honest. In my brain, I'm thinking, you know, seconds, dot, then 3 more zeros, milliseconds, and then 3 more zeros, microseconds, and then 3 more zeros. Those are nanoseconds. Okay. So, but now, can Wireshark go ahead and read a file format if the file format contains nanoseconds timestamping? Can Wireshark go ahead and display nanoseconds? Yes, sir. Certainly you can. But can a PCAP do nanoseconds? I'm under the impression absolutely not. I'm trying to get confirmation up here. Yeah, I'm correct? Okay. That's the thing. I mean, I'm right? Okay. So, yeah, no, PCAP. All right, so let's go back to Greg's comment of, well, you know, do nanoseconds matter? It depends.
This is a nanosecond. 1 international nanosecond, 1 foot, within a percentage. It's hard for electronics when you have to go through switches and delays and analysis to actually do that sort of thing.
Yes. But are there capture devices that will go ahead and give nanosecond timestamping? Yes.
EDMS,
EDMS. Help me
time
out.
domain reflectometry systems.
Okay.
Basically, it's radar. You slam a square pulse down a wire, you get the reflection back, divide that according to voltage off. You find out where the break of the wire is. You don't have to do your trick. You know exactly where it is.
Mm. See, I've never read fibers. I did not know that. Cool. Okay. But from a capture device standpoint, okay.
You have so many transistors to go through. I just feel you're pushing it.
I know. Okay. I'm just trying to tell you what's available, what's not available. All right. So, because usually, all right. So, but in respect to his point, most environments, nanoseconds don't matter. It's one of the reasons PCAPs don't do it. However, if you're in, let's say, who does financials? Who's in a stock trading environment? Who cares about microseconds? Amen, brother. So, yeah, so it depends. Okay. One of my biggest customers is in Chicago, and nanoseconds matter.
CDO.
I know. Okay. And so, anyway. Yeah, and they've got capture devices that go to nanos. So, all right. So focusing. Okay. Now, so I've got my tap device, you know, at the switch, at the servers, because I'm interested in it as accurate of time stamping as possible. That's why I don't like to span. I don't like to span. Now, sometimes you just got to suck it up and do what you got to do, and set up a span session where you configure the switch to go ahead and copy from interface 1 to interface 7, because that's where the sniffer's plugged in, right? So, you know, and if my switch will do that, that's all well and good, because from a logistical and change control situation, it's kind of easy to go ahead and span from port 1 to port 7 and capture those packets. But from a time stamping discussion, I don't really like to span, because there's a whole discussion on that on Love My Tool. www.lovemytool.com, which is where all the fabulous videos are going to be that Denny's filming for y'all. And if you have not been there yet, you need to go. All right. Okay. From my presentation 2 years ago. Okay, you'll find out how I feel about that. Now, okay. I know, what were you thinking when you needed that? All right. Okay. So, anyway. So you can go ahead and do a span session if you have rights to the switch, if the guy who has, you know, the password for that switch is there, if there's still an interface available left on that switch for you to send the span to, if the switch is not oversubscribed already, if once you set it up, you know, before you set it up, you like checked all the memory statistics on it, because the memory utilization is going to be your issue when you do a span. So I'm watching the memory statistics beforehand. I set up the span. I want to watch my memory statistics afterwards to make sure I'm not oversubscribing the switch, because, you know, if I'm on a switch, you know, I got a nice little Cisco 6500. Am I concerned about setting up a port 1 span over to port 7 span? Do I like stay up at night worrying about that?
No.
No. Yeah. Well, as long as I don't make a loop, though. Exactly. Okay. I did that once in an attorney's office. But, all right, so in my defense, okay, it was not a Cisco switch. And you know, on a Cisco switch, the syntax is from and to, right? Not on the switch that they had. And I made a circle. At a law office. God, of all people, who's going to sue you for that? Anyway, so what your errors and omissions insurance is for, if y'all are considering doing consulting as a job, error and omission insurance is a beautiful thing. All right, I'm just saying. They didn't sue me, thank God. But, all right, so at my client now, as I'm watching them, don't click on the little bed all right? Then over here, I've got a nice little mirroring switch that does it for me. Because I can go ahead and find out, number one, I'm like sitting there with Susie, right? She's all set. I got to now find what switch Susie's connected to, what interface she's on, is there stuff available on that thing, you know, can I go ahead and set up my computer on it, blah, blah, blah. Or to, you know, to do a span there and then leave my computer in the data center all day. Or can I want to sit right there next to her? Okay. So I like to put these in. This is a port mirroring switch. And what it is it's hardwired to go ahead and mirror from port 1 to port 5. So I don't configure it. There's like no hole in the back for me to like log into it and telnet and configure it and anything. It's just hardwired to copy port 1 and port 5. And that way I can go ahead and capture her because, you know, doing the change control from port 1 to edge 1, unplugging that, was an issue. If I tell Susie, you know, they hired me to come in here and go ahead and make this application faster for you, if you could just help me out a little bit, she's going to let me unplug her computer. She couldn't care less. All right, so that one's not a problem. All right, and so these are great for that. Now, other things. Cable testers. Oh my gosh, we already saw, we start at layer 1, right? If you're troubleshooting your little OSI model thing, the first time you went to a networking class, you learned about OSI model, right? Was physical layer. So if I have a cable problem, I need a cable tester. I love this one because it'll go in line. So if I have a duplex mismatch, I can tell that. Okay, so that's why I love this one. eBay. Okay. And then if I'm capturing in a wireless environment, which is what the one that we did yesterday, the mystery we did yesterday, I have to have some type of card that will capture in RF mon mode in 802.11, the 802.11 headers. Okay. And of course, I use AirPcaps for that because I use Windows. But there's all sorts of, you know, ones that'll do it in either your MacBooks. I see like half the room's got an Apple book, right? Or on your Linux boxes, you know, yeah, really, seriously, about to, you know, download, you know, anyway. So you know, we can do it in Linux with no problem, but if you want to do it in Windows, one of the easiest ways to do it is with the AirPcap drivers. And some kind of long-term capture device. Now, and then of course we've got to look at it. And in my disclosure here is I cheat and use Pilot because I never capture filter. It's like a thing with me. Because you don't know what you don't know. So I don't want to set up capture filters because I might filter out what the whole problem is. Because let's say that Susie's the one pitching the hissy fit, and the whole reason is because, you know, Fred here, he seems so nice and innocent and everything. You know, you've been running that denial of service against her this whole day, okay? So, and if I go ahead and I filter on her IP address, I might not see, oh, hey, Jeff, with the great big giant stacks of stuff, okay? Hey, darling.
I'm sorry.
No worries, come on in.
You said go through the doors, but I got stuck.
You go right ahead. Okay. Okay, so the gentleman who did the IP hands-on, IPv6 hands-on lab. Okay. So poor Fred down here is doing an art flood against poor little Susie, and that's the whole reason that we're having an issue. And if I do an IP capture filter on Susie's IP address, I don't know that. Okay. So I don't like to capture filter. So because of that, I use Pilot quite a bit more than I use Wireshark because it's a little easier to work with a lot larger trace files. However, you missed a little bit earlier though, where I tried to load Pilot 3 times and haven't been able to today. It's all good. So by now, we're really hoping that since everybody's done downloading the files, I'll be able to load Pilot, because you know that's what the problem was. Yeah, yeah. Good. Loaded up just fine. Yay. Okay. Because, yeah, I think the issue was, oh, hi, power. I forgot I never did to plug this in. Sorry. Because I think what the issue was is we were all hitting the FTP server at the same time I was trying to load Pilot. Yeah, that's what the problem was. All right. Let me power up here. Sorry. Should have had that done. I got distracted.
What kind of port mirroring switch do you actually use?
That one? It's a dual-com, John from dual-com, okay? And actually, the cool thing was I had a student in one of my Wireshark U classes, because I teach all the Wireshark University materials that Laura Chappell wrote. Okay, and did y'all go to Laura's sessions? Is she fun? Yeah, she is a hoot. Okay, and so anyway, so the Wireshark U class, I had a student, and I was showing my tabs, because I do love my tabs. Okay, I'll just be honest with you, John, I love my tabs. And then I said, how much my tab cost. He was like, there's no way, there's got to be something else out there. Okay, and he went and searched out the internet and found John's site and bought himself one. So then he comes to the Core 2 class with it. And I'm like, and he had bought one of the little ones. And he brought it in class, and I'm like, oh, wow, cool, what's that? And he started telling me about it. I'm like, wow, that's nice. Because it does PoE pass-through. So for your VoIP phones or your access points, right? I want to tap it in front of the AP. I need power over Ethernet, so we'll do PoE pass-through. And so he had that, so we tested it in class. And I perfed it so that we could see whether or not it was keeping up. And then and it did no problem. So I went out ahead and reached out to John and got me a couple. So, and it's all just because a student brought one into class, and I thought, well, hey, new toy. I want to play with it. Okay. So that's how I actually found them. And I'll be honest with you, most of the stuff that I have or I've done is because somebody showed me something cool, and I was like, oh, me too. So that's how I get all my good toys. Okay, so the mystery we're going to look at today, all right, in, wow, dang, 45 minutes. I talked a little bit longer than I thought I was going to. Sorry. Is companies just invested in hundreds of new thin clients for the call center. And actually, they've been working on this for about 2 months. The project is on hold, however, because they can't complete the image download. The vendor has been called in quite a few times. And of course, the vendor is saying, it's your network. Which, that's what the vendor says. It's their job, right? So the customer is like, hey, Betty, can you come on over? And it happened to be out in Alpharetta, which is just north of where I live. The customer's out in Alpharetta. He's like, hey, Betty, can you come on over and try to figure out what this is? Because we can't figure it out. Now, so we've got a thin client going to download an image. What are our suspects? What are some of the things that we should talk about?
ISP.
I'm sorry, say louder.
The ISP.
The ISP. Okay, well, now, if we were downloading that from, okay, so I should give more information, right? Because we need to ask these kind of questions, right? Well, gosh, Betty, do they have to go ahead and download the image through an ISP from some other place? But actually, the place that they're downloading the file from is internal. It's in the building. Okay. So, all right. So, wait. What am I talking about? All right, I gotta write this down. Okay. So our possible suspects. Okay. We've got a firewall discussion. Bingo. All right. You already got a shirt though. Here, just 1 second, Joe. Okay, it's internal.
Client.
Wait just 1 second. No, wait. Okay, so it's internal, so more likely it ain't a firewall. Now, Joe had his hand up. Joe.
Well, I think if you had to pick 1, 2, 3, I would say the server, the infrastructure, or the client.
Well, now you got to be more specific now. Now bear in mind now, Joe and I have known each other a long time, so I can say that to him now. But he's right.
The other question I would be asking too is, the customer is saying they can't complete the image download, and that opens the door to some nuance of meaning. Is the image actually downloading, but then there's a client issue where it's not integrating? Is the image failing? That description raises a big red flag for me.
Okay, and those are the kind of things that we want to ask. All right, so the customer literally said, we can't download the image, can you come and help? I need a little more info, sweetie. All right, so, okay, going back to Joe, what are the kind of questions we should ask? So, okay, now we already know that it's not through an ISP, so we are downloading it from an internal site. So the server is in the building.
What protocol?
What protocol? Okay. So I have a question. What protocol? Now, do you mean, be more specific?
How are you downloading the file?
How am I downloading the file? What protocol am I using to download the image? All right. And it's FTP. Now, can I ping the server? Yes, all right, because they're not paying me $1 billion cajillion every day. Cause, they've already tested ping the server, so but never assume because you don't know what you don't know, right? But here's the second, Jeff. Okay, so we are doing an FTP transfer, and if you've downloaded the file, feel free to open it up in Wireshark. All right, go ahead, Jeff.
Is it V4 or V6?
Oh, now you know it's V4. I don't know nothing about IPv6.
Neither does the vendor. Okay. Load balance, virtual, questions? All right, so for the server, is it on a BIP? Is it load balanced? All right, tell me a little bit more about the server. Now, let's try to remember whether or not the FTP server was load balanced. I really want to say, right, okay, so I had to think, kind of roll back in my head, 2 years. And think about that. But, no, there was one FTP server, because remember, we just bought a whole bunch of these, and we can't get one to work, let alone all of them. So they were smart enough to try one thing at a time. So right now, we've only got one FTP server. Are they all on the same VLAN? Okay. Now that one I don't remember. So, oh, wait, just one second. Wait, okay. Now, so if I want to know, are they all on the same VLAN, what's going to be the easiest way in Wireshark to tell that?
Protocol?
Well, no, not protocol, but like a Wireshark feature.
I'm thinking SSL.
Like a feature in Wireshark. What kind of thing do I want to open up in Wireshark that would tell me, these two IP addresses, are they even close to each other? Yeah, that's what I want to hear, conversation. I'm telling you, he's like kick it up. He's already got one T-shirt. And
I've done an early switch.
oh, yeah, wouldn't that be cool? Yeah. Okay, conversations. All right, so let's open up our trace file and let's see. All right, while Wireshark's loading up, bear in mind that this is your network diagram. So I've got a thin client hanging off a switch, got my tap, got my thin client,
Where's the server?
got my Wireshark on the other side of that switch. Okay. So now, and I don't,
So it's a layer 2.
could be.
The layer 2 or layer 3?
It's a layer 2 because it's a rectangle, and I would have drawn it if it's a layer 3 as a circle. But you're right, it's an excellent question. Because, some people, a layer 3 switch is a switch. In Bettyland, a layer 3 switch is a router, even though it's really a switch. So, that's a good question. All right, take here. That sounded encouraging. Plus participation. Good. All the vendors last night who had T-shirts left over, I hit them all up. Oh, you don't want to take those home? I can pass them out in class. Okay. So, yeah. All right, come on back into Wireshark here. There we go. Let's go ahead and open up that trace file. Let's see. Miss and download. We'll go ahead and add in conversations. Now, all right. So we're downloading that file. Now,
looking at those IP addresses, okay, you think they're on the same subnet, on a different subnet? Okay, what's the subnet? That's what I'm hearing. All right, now who said that? But Joe had his hand up.
Right, and that was the same comment.
Yeah.
Since it certainly could be a.
In the blue shirt, right?
a
You said what subnet?
/24 Certainly could
Yeah.
be a /24 subnet. Which my next thing would be to look at the time to live in the IP header of the frame coming from the server, since your network diagram, which is consistent with the incomplete picture that the end user painted, it's a mystery on the other side of that switch.
That's why we call them those, Joe.
So we
Okay.
can confirm that even though we have no direct way to see what the subnet mask is.
Ah.
Take a guess.
All right, now hold that thought for just a moment. Do we have a way to tell what the subnet mask is in this environment?
That's one.
Well, yeah, but in the trace file.
DHCP.
There we go. Who said it? DHCP. All right. Okay. So if I have a packet with DHCP, then I would go ahead and know what the subnet mask is. Oh, I thought for sure I was going to hit Denny in the head. Okay. So if I have a packet that's got DHCP, then I would definitely know, what the subnet mask is. Or, like, let's say I don't, then totally what Joe just said, I could go ahead and look at the time to live in the IP header to see whether or not, because I'm capturing the client. I know what the hop count is when the client sent it, and I could be able to look at the hop count when the server sent it back. Have I gone through a router or not? All right, I've gone through a router. Okay, now, so we're still at the thin client. Okay, now we still haven't quite talked about kind of one of the most important things, but. Now, when asked how we downloaded the image, what else should we discuss? Who are the accomplices? Okay, so downloading the image is the issue. Okay, and we use FTP to download the image.
DNS.
Okay, DNS. Because we're looking for the interdependencies. That one's hard to say. So we're looking for the accomplices. So, could be a DNS protocol involved. Okay. What other protocols would be involved? You were about to say something, right? No? Or just kind of over in this area? No? Okay. I heard something. All right. So DNS could be involved. ARP could be involved. It's a thin client. Has no, that's what I want to hear. Roger, thank you, sir. Okay. Boot P. All right, it's a thin client. How do we even know where to go to download the image in the first place? Okay, yeah, boot P, DHCP. All right, so my accomplice, okay, is going to be DHCP. And from DHCP, I'm going to go ahead and know where I'm supposed to go ahead and download the image. And I'll also get my DNS server. And I'll be able to go ahead and figure out how am I even supposed to get there and my subnet mask. Okay.
What about RPC?
What about RPC, remote procedure call? It's FTP, it's not NFS.
Oh, all the same clients I've experienced, they have repeated and pulled down Citrix from a Unix box.
Gotcha. And these were, of course, you'll be able to figure out the vendor as soon as you look at the MAC address. But these boxes, they pulled it down via FTP. Kind of new and different and unexpected. Yeah, I know, but yeah, I don't make these decisions. I just, show up. I don't judge. And I'm Switzerland. I'm neutral. Okay. So, yeah, let's put that in the video. Okay, especially since you're here from the sheriff department. I'm just saying. All right. Yeah. So let's go ahead and look at that one. And here we go. So we've got our trace file, and we've got our conversations. So I need to know You know, so if I'm using DHCP to pull down all this information, what am I going to need to look for in this trace file?
Broadcast?
Well, DHCP does go out as a broadcast, yes. Right, am I going through a relay? Okay. So if I'm using DHCP, am I going through a relay agent? You know, and if so, did that work? Okay. So I need to know, did the whole DORA process work? Right? Discover, offer, request, acknowledge. Did that whole process work? And if it did, what kind of information was received by the DHCP client? You know, what was in the offer? Okay. So let's filter for BOOP. Because you can't filter for DHCP. Because all DHCP is BOOP with options, and all your protocol filters are based on the port number, and height 6768 is still BOOP, even if it has options and is really DHCP. So you don't type in DHCP. Okay. Now, so looking at my DHCP packets, anybody notice anything? Anything jump out at y'all? I'm sorry, say louder. Mm-hmm. Long deltas. You notice they're purple? Okay. Now, who got to go to Laura's customizing with colors? Isn't that fun? Okay. Now, with Laura, she's got like a thing for orange. All right. And she colors everything orange that she didn't like. Okay. Now, in my world, remember, the biggest thing that I do is get paid by the network guys to prove it's not the network and it's the application. So I like, I'm just being honest, man. So I like to go ahead and look for the large deltas between a command and a reply, and I like those to jump out at me. So I equate slow response time with purple. Okay? So anything that has a delta display time greater than 2 seconds is going to get colored purple. All right? Now you have to bear in mind, remember I started out with Network General. You would be absolutely amazed how many hours and hours and days and days and days of my life I have spent, here just one second, I'm going to make them all the right width, there we go, scrolling through a trace file, hunting for the big delta times. Okay? Because you couldn't filter based on delta time in the sniffer, and you sure as heck couldn't sort by it. So the fact that you can do that in Wireshark is so fabulous. It's like my favorite thing. Right? So I've got really big delta times. Okay. Now, anybody notice anything else? So we've got big delta times, all right, in between the informs. Are all those informs coming from the same person? They're all coming from different sources. I ran out of t-shirts, I'm sorry. They're all coming from different sources. Okay. So, you know, I did a filter. I'm capturing on a tab. I'm going to hear broadcast traffic from everybody on that subnet. So I'm going to hear those informs from other people. And they just happen to be spread out. So while interesting in the big delta times and all the purple packets, not relevant. Okay? In the South, we call that a rabbit hole. So we've just gone down a rabbit hole for nothing, all right? Now, what else do you notice?
There's no offer?
There's no offer. Yeah, it's supposed to be discover, offer, request, acknowledge, DORA, okay? Or as Laura likes to call it, dork, okay? Because, you know, that there's a K in acknowledge, all right? So, whatever we have to do to remember stuff, that's what we have to do, you know? So there's no offer. I actually don't have an offer in this trace file. Okay. Now, okay. Now, just to let you all know, the trace file has been edited, but it has not been filtered. Okay. So what that means is, obviously, I wasn't either capturing long enough, or I didn't capture the discover offer process. All right. Or the client already had an IP somehow in its cache. Okay. So, no discover offer. Now, Anybody notice anything else?
Unreachable port.
There we go, thank you. Okay, I've got an unreachable port in there, it's red, all right. I've got a destination unreachable. Okay, port unreachable. There we go. Okay, for what port? For boot B. For boot B. Okay. So now remember, with ICMP, whoever detects the error reports the error. So at some point, our DHCP server went ahead and came back to .140 and said, oh, by the way, all right, okay. Actually, let's see, am I getting it backwards? Yeah, destination, oh, sorry. So destination 251, 140 is our boot server, or whoever they were talking to. Okay, said, just want to let you know, you tried to go to destination 68, boot client, and I want to let you know that port's closed. So the boot server sent the packet, and the client was closed. Okay. Now, so when I look at that, now am I worried about that boot client? Trying to get the download? Yes? If, because there's, you know, there's no such thing as a yes or no question in Bettyland. All right. Yes, you're right. If.
That's the correct server.
Yeah, that's the correct server and client, which it may or may not be. You know, and they're not paying me to look at all the other stuff. Okay. So I don't care about that. While it may be interesting, we don't know necessarily if I care or not. Now, so let's go ahead and look back in our conversation list. All right. So back, the one that's actually doing the FTP, or go ahead and sort it by bytes, right? Oops, let's try that again. Sort it by bytes. Okay. The client in question that we care about is that .140, so it is the client. Our client is telling the boot server, hey, I'm not listening on that port. I don't know why you're talking to me. Okay, that can't be good. All right. Now, to let you know, in other trace files, the same client was able to go ahead and get an offer. All right. And they are obviously using the .140 address. Okay. This is not a trace file of a complete power-up. It's a trace file of the download itself. So when you're taking your trace files, you have to note that within the, I personally, you know, like some people like to write the stuff down in a little notebook. I like to go ahead and have trace file names that are about this long. And you know, if you were to look at the original file of this, its name was capturing of the download off a tap, but not the first actual boot up. So this client's already got an IP address, and we're actually looking at the download itself. So we do not actually have in this trace file the whole boot process. Okay. Now, so we've got an IP address, and now we're actually trying to download the image. Okay. So what protocol should I focus on now? FTP. So now, does anybody notice anything about the FTP conversations? They're small? Is that what I heard? Yeah, they are. They're kind of small. All right. Bear in mind the image. Okay, now so that should be a question we should ask, right? We're downloading an image. What question should we ask? Thank you. Okay, if I had any more teachers, I'd give you another one. All right. So what is the image size? Okay, it's 40 meg.
We can see that on the control.
Hey, I don't judge, all right? I don't. I do try really hard to maintain a straight face, though, while I'm at the customer site, which is not always possible. Yeah, it's a pretty thick, thin client, isn't it? But I don't judge. So it's about a 40 meg image, okay? So not quite, you know, getting the whole thing downloaded. Sir?
Okay, specified image. Is this like an image of a backup, or is this an image like a picture like a JPEG?
Oh, okay, I'm sorry. So the image that we're talking about, we've got a thin client who has no operating system.
Okay.
All that it has on it is just enough to do boot P and get all of its data from the boot P server. Number one, things like who's the DNS server, right? And then the next server in the list, in the boot P thing, is who he's going to get his FTP image from.
Okay.
So it comes back with everything that he's supposed to know about, and one of those things is, where's the image? Okay, to go ahead and download. And so it's pretty much installing the operating system every time it boots up.
Right, it's an image
Yeah.
of the OS.
Yes, it's an image of the OS. Okay, so,
That's a small image.
yeah. You know, you think pretty much, that's quite a lot, but when you think about the fact that it's a whole OS, it's actually not, but yeah.
Yeah, I was thinking of GIF because I'm thinking, okay, maybe Photoshop, but for an OS, it's a whole different story. So basically, they're unable to use their computer.
Exactly. So we've got a whole bunch of, yeah.
Yeah, so they're like...
And they're in a call center. So you can imagine if you're somebody in a call center and your computer boots up first thing in the morning and it doesn't really boot up, you're a little annoyed. And if you've just bought hundreds and hundreds and hundreds of these little boxes, you're having a little conniption fit there with the vendor. And you've gone, yeah, they spent a lot of money. And they've been going back and forth for about a month about whose fault it was. Okay.
Wow.
Yeah. Yeah. So I come into Switzerland and figure out whose fault is it. All right. So yeah. So I'm sorry. I should have been more specific about the image when we first started. Okay. Now, okay, where's my mouse? Way over there. So did the download complete in this trace file? So now that we know that the image is 40 meg, did the download complete in this trace file? No. Okay. Now, let's say that my goal was to go ahead and look at one of those conversations. What would be the easiest way to do that? Right click. Okay, you've been to Bedland before, yeah? Because you know we got to right click. All right. So I'm going to go ahead and apply that as a filter. Go up to the top. All right. Now I could have just as easily clicked on a packet and said follow TCP stream, and then I would have gotten a picture of the image as well. A dialog box pop up, you know, follow TCP streams, red thing in Wireshark, right? You guys came on Tuesday. Okay. So when we're looking at that, now what do we need to look for? So let's think about it for a second, because remember, we're still in the question asking stage. All right, we've gotten an address. We're doing something FTP-wise. It's not necessarily everything we need, but we're doing something FTP-wise. Because you know, I'm capturing all this data and I'm looking at it as it's happening, as the machine's booting up and trying to download the image. All right, so I know there's some stuff going on. Just might not necessarily be the right stuff. All right. So FTP is coming down. Now, what are the things that we should kind of look for, considering the fact that FTP ain't working?
Is there a username and password?
Okay, username and password. You know, specific FTP issues.
Permissions.
Yeah, like permissions, exactly. All right, so permissions are going to be next. So whether or not, you know, you've got the right username and password, and are they correct? Okay. Then, do you have permission to the file you actually want to retrieve?
We want to ask if there's a middleman, like a load balancer or something.
Load balancer or something? Now remember though, because when we started and we were talking about how whether we didn't pull it off the ISP, that, did you ask about the load balancer? I just know that it came over from this direction. Okay, help me, Terry. Okay, I'm like, I just know it's over here. Okay. So when we were talking about the ISP, we said that remember that the server's in the room, in the building, and it's just one server, so nope, there's no load balancer. But yes, that would be totally a question, depending on who are we going to. So in the boot P response, it says this IP address for your FTP. Okay. So actually, we didn't even have to do DNS. We got the DNS info in the DHCP, but we actually haven't used it yet. Okay. So what else should we look for? The TCP process. Remember, we started at the bottom, we work our way up, right? We checked all the physical layer stuff. Okay, not having any physical layer problems. We checked IP. We can actually get there. We can ping it. Now moving into layer 4. What are some of the things in layer 4 that could be a concern? Windowing problems, all right? So windowing issues, windowing, there we go. All right, windowing issues, what else? Packet loss. Okay, anything else? I mean, those are my big dogs right there, the two things I'm looking for, but you know, hey, I'll look for other stuff too.
Retransmissions?
All right, retransmissions, okay. If I have packet loss, therefore, I will have retransmissions. Okay. So if I'm trying to see if I've got a packet loss issue, I'm going to go ahead and look for retrans, all right, or fast retrans. Now, yeah. So who went to Laura's class and knows the difference between regular retransmission and the fast retransmission? Okay, fire it off. There you go. The difference between in Wireshark, difference between a fast retransmission and a regular retransmission is if Wireshark goes ahead and sees two duplicate acknowledgement numbers and then a transmission, at least two duplicate acknowledgement numbers for a sequence number, and then sees that same sequence number coming from the other side within 20 milliseconds, that's a fast retrans. Now, at least two. Could be 200. Doesn't matter to Wireshark, it's still going to be between the last duplicate ACK and the retransmission. If that took 20 milliseconds, it's going to be called a fast retrans. Okay? So, now what would be the easiest way for me to go ahead and look to see if I've got lots and lots of packet loss? Oh, sure. Like I could oh, there's my clicker way over there. I could scroll through the trace file and look for retransmission.
Filter.
Amen, brother. Okay. No, and scroll through a trace file. And actually later we actually will scroll through the trace file. But okay. But if I want a really, really fast way, okay, I could filter for retrans or yeah, totally. Or
Press the easy button.
yeah. I'm going right for the easy button, right down there, okay? So I'm going to go ahead and click on the easy button. Come on down. Here we go. Okay, whoops, wrong easy button. Try that again. It's really hard to get on that button. There we go, there we go. So I can go ahead and pop up my expert. Okay. And that'll go ahead and tell me my warnings and my notes. How many retransmissions that I have. So I have 53 suspected retransmissions, those are the regulars, and 8, fast retransmissions. What else do you see? Windows full.
Zero window.
Zero window and
Previous
Windows
segment
full.
lost.
Previous segment lost. Now if I've got a segment loss, that goes back up with my retrans issues. Okay, that's another symptom of packet loss. So it'll cause retransmissions, but also things will happen is you'll have a segment loss. Segment lost. Okay, lost. Here we go. All right. Okay, but yeah, there we go. I've got a full window.
The
I gotta
most counts.
Hmm?
The most counts on a full window.
Mm-hmm.
That switch could be doing something, or that router could be doing something.
The switch or the router could be doing something. Now let's go down that road for just a second. Okay. Now, so a window full. If you see a packet that's flagged in Wireshark, TCP window full, where do you look? Well, yeah, I mean, you look at window size. I'm sorry, let me be more specific in my question. I'm not phrasing that right. Who do you look at? What are your suspects for a window full? Do you look at the client? Do you look at the server? Do you look at the switch or the router? It depends. Always the correct answer, right? So now, all right, so if I have a packet that Wireshark says the window's full, what that means is whatever data is in this packet is enough to fill the other guy's last advertised window. That's a window full. All right. So if I'm the server, I'm the FTP server, and my packet that I'm sending to Fred, my FTP client, is, flagged window full, what that means is, all right, so I'm the server, my packet got flagged window full. Is my window full or is Fred's window full? Red. Okay. So you want to look back, you want to be careful how you look at a window full. All right. Plus you've got, okay, in your expert, come on, back up there. Okay. And you got some zero windows. Okay. So we've got window full, and we got some zero windows. Zero windows means that my window size is 0. So whoever is the source of a window full is not the culprit, it's the destination. For a 0 window, whoever is the source is the culprit. Okay. So you got to be careful how you look at that. All right. So 0 window, whoever's the source of the 0 window, it's their fault. Okay. Whoever's the destination of a window full, it's their fault. All right. So you want to think about that before you look at them.
Is that due to the advertisements?
Is that due to the advertised window size? Because remember, a window full means there's enough data in this packet to fill the other side's last advertised window size. All right, and it's a Wireshark thing. All right, it may or may not necessarily still be true. Because let's say that Fred just told me that your window size was, 1,460 bytes, right? And I go ahead and y'all are capturing at me, right? I got a cap right here, okay? So Fred just sent that to me, okay? And I go ahead and I send a packet with 1460 bytes. Well, according to Wireshark right here, oh my God, his window's full. You just filled it. Meanwhile, Fred's like, yeah, I've already dealt with that packet and I'm ready. Go ahead, bring it on. It's all good, right? And he goes ahead, pushes it up the stack, sends me a nice, beautiful app. Do I care that I filled this window? No. So in Bettyland, in my coloring scheme, I don't even color full window. It doesn't even have a special color. Now, 0 window, if Fred, you go ahead and you tell me that you've got a 0 window, that one's colored red, because that means no more data is coming. I'm not allowed to do anything except maybe send you some window size probes saying, hi, got any window yet? I'm not allowed to send him any more data until he updates his window size. All right? So a window full may or may not be an issue, but a 0 window is always an issue. Okay. Now, yeah. Let's go ahead and get the file back up, and then the expert back up. Cool, because I got like 5 minutes. All right. You didn't get a chance to show it to you in Pilot. Oh well. Okay, so I've got a 0 window. So now, what I'd like to do is look at the pattern of that. And I am actually going to scroll through the packets. All right, so I've got a 0 window. I've got a 0 window update. Excuse me, I've got a 0 window. And then I've got a window update. How fast do those two things happen? Pretty fast, Okay. So 140 is the client. So the client's like, yep, my window's full. Oh, it's big again. Okay. Now you notice like window update in Bettyland is pink. It's a good thing. I have 2 girls. Pink is a good color, all right? So it's a good thing, so I color it pink. All right. Then the next one. Okay, same thing, 0 window, TCP window update. Still happening pretty quick. You're not even moving. I bet you I'm on the wrong conversation. Let me clear my filter. So I may or may not be on the right packets. There we go. Let's try that again. Okay. Open. Thank you. Oops. Try it again. There we go. Okay. So in a 0 window, we recover quickly.
Yeah, you're moving.
I am moving. Okay. Because it's wild. At the top, I did not see movement. But then, yeah. We noticed right down here, it did have some movement.
That delta time, so I'll give it away.
Yeah, okay. So, because you're right, as you stare at these long enough, You know, if you've been on any Hansong's presentations, believe me, your eyes get trained to look for certain changes. Okay, so that's why it's like I'm not even moving. All right, so I am moving. Okay, good. Okay. Same thing. We recover. Same thing. We recover. And we are recovering pretty quickly. Okay. So no problem. Okay. Now, if we're downloading the file, though, all right, how can the whole file not get downloaded? Okay. So I've got my filter off. All right. If I'm downloading the entire image, what should be down at the bottom? Pins. All right. So we were in this trace file for the ones that we just looked at. We did recover from a zero window pretty quickly, right? However, if I come on down to the bottom, okay, yeah, okay. What do you guys see? Resets. Resets. Now, in the expert, is there a spot for TCP resets? Can I like go right to those like I did my zero windows? Does anybody know? Oh, come on, guys. There we go. That's what I want to hear. You're right, not in the notes or the warnings where you think it should be, but yes, in the chats there are. So you get a hunt for it. Okay. So.
But it says FTP transfer complete and then you reset.
Yeah. It says FTP transfer is complete. So according to the server, the transfer is complete, but we certainly didn't download the image. Okay. So if we look at the FTP transfer, if you look at the file going back just before that, then this response, if I'm going to do a filter just for FTP, okay, and down to the bottom, okay, what is that, good response for? Is it for the retrieve or is it for something else? Yeah, it's for the LS. So that completed. All right. But the retrieve, all right, if I wanted to go ahead and hunt for the retrieve, what would be the easiest way to do that? Okay. Yeah, filter. TV dot request. Actually, you know what I would do? Clear. I'd do a hunt for RETR. Okay, oops. I remember to hit string. There we go. So there's my retrieve. So in the retrieve, that is the conversation that I'm interested in. All right. So in the control piece, and I look at all of the window updates, and everything, and looking at that, bear in mind, the whole goal is to download the whole image. That's the conversation that I'm interested in. And that's the one that I need to filter for. So we've got a data connection. We've got a retrieve remote. Data connection's already open. This is the one that I need to focus on. We'll follow that stream. Okay. Anybody notice anything?
That image is bad.
Here's a little problem with the image. Okay. Now, yeah, it was really pretty funny when I did this during the debrief with the customer and showed that. Because, I don't judge. I'm like, do you think it's supposed to say that? Okay. Now, two things are going on in this trace file. There is the one that y'all just saw. Okay, we want to look at the image itself, and the one that you see in the video, the windowing issue. Because as you look at this trace file, one of the things that happened in some of the other downloads is every time we started downloading this whole image, that was a weird noise, okay. Every time we start downloading this image, the client would receive a nice big chunk and then have a zero window. And then recover, and the ones that we looked at, we recovered and the download continued. Okay. As long as we recover, there's no problem. But in looking at from the trace file in the video is sometimes when we hit the recovery, the window full and the 0 window, we don't recover. And there's a timer for how long it takes to do that recovery. You exceed that timer, what happens if I go ahead and, let's say I'm trying to download some stuff off of Jennifer, okay? And I go ahead and start saying, I really want that file, okay, but don't actually send me any right now. But I really want that file, but just not right this second because my buffer's full. She's only going to wait so long, and then what will happen?
Drop.
She'll drop it. What will a drop look like in a trace file? TCP resets. Okay. So if somebody says a TCP reset, that means something bad happened. Okay, unless it's an HTTP client, and that's a whole different discussion. But in this trace, if I want to go ahead and look for my resets, okay, clear, go back to my expert button. Remember how you said now, okay, the Dallas Cowboy shirt, who doesn't have his little badge so I can see what his name is, you said they were in the chats. You guys notice a pattern in those numbers?
Connection, reset, 33.
Yeah. I got 33 resets. Okay. Now, for my sins, handshakes, I've cut 3. And yet, for my fins and my resets, I got like 33. That's probably not a very good, ratio. Okay. So, I had a little problem with my resets. Okay. So what's happened is every time the client's got too much buffer, number one, the image was bad. Bottom line. Number two, and we saw that in the follow TCP stream. Number two, as the client was downloading it, we would get to a point in that 40 meg download where it was just too much for the client to handle, and their window size would go down and then come back up, and that's okay, but then it would go down and stay down for too long. And the client was actually sending the server resets. It's like, I can't handle all the data. Sorry, Jennifer, I don't really want it. Reset. Okay. So, when you look at the resets, except for if it's an HTTP client, and that's a whole different discussion, whoever sends the reset, they're the ones who have detected the issue. Okay. So, now it's 3 o'clock, so I'm going to stop. All right, so there's our network mystery, and we've solved it with 2 different solutions. Yay!